So where do you
Oh, okay.
Python? A Python developer is a what? Is he a front-end developer, a back-end, or full stack? That was the question.
Okay, so thank you for that question. So basically, when we talk about web applications, every web application has a client and a server,
Server.
right? Now, the server is typically the interface that you see, and the server is some remote software that some remote thing somewhere in the cloud or somewhere else that you don't get to see. So which means that a web application would have an interface on the client. So a web application would have a client interface and a server back end. Or typically, when you hear back end, server, whatever, the server side, back end, and so on and so forth, they all belong, they are all the same thing, server, back end, whatsoever. So now this means that for everything that you do on the internet, on a browser, I won't say for every mobile app, but for most mobile apps are basically just client interfaces talking to some software somewhere. So there would be a client interface and there would be a server side. So client interfaces are generally where your HTML, CSS, JavaScript lives. So you basically would use these three technologies when designing client interfaces for the web. So when we say front-end developer, a front-end developer is responsible for creating client interfaces, right? So typically a front-end developer, as far as the web is concerned, would typically just focus on HTML, CSS, and JavaScript. Now, when you see a back-end developer, he would typically focus on Python or also JavaScript or Node.js. What you know as Node.js is JavaScript with your runtime anyway. Java, C#, Ruby. Yes, people still use Scala, Groovy, and so on and so forth, right? Now, when we say what then is a full stack developer, right? So how does full stack, what does it mean to be a full stack developer? A full stack developer is someone who is capable of creating the client side and the server side, right? Now, it may be using a framework. It may be deciding to write everything individually. You write the front end in HTML, CSS, in JavaScript, or whatever. And, deciding to write the back end in Python or whatever. But the fundamental thing is that a full stack developer is not restricted to just working on the client interface or on the back end. A full stack developer is capable of working with client-side technologies and back-end technologies. Is that clear enough?
Bertrand, is that clear enough?
Yes, yes.
Yeah. Okay, so yeah, back to our Python stuff. So, like I said, Python, oh, sorry. So like I said, Python is functional, which means that you typically just type functions, call functions, and you are good to go. So which means that a Python script, you can typically open a script and start hacking away, and you are already writing software. But as far as Java or other OOP-based languages are concerned, you'd have to talk about a class, the method, and then before you start talking about what you want to achieve. So how does this? Where do we begin from here? So for every program you write, you typically work with variables and you typically work with variables and expressions, right? So basically, most of what we do in Python, most of what we do in Python would be working with variables and expressions. And for the better part of today, this is what we do. We'll be doing, getting acquainted with the nitty-gritty details of expressions and variables. Now, what is a variable? A variable is basically a statement to the compiler or interpreter to reserve a space for something in memory, right? So basically, you are saying, if I say I is equal to 5, I am telling the Python interpreter to tell the computer to reserve memory, right? And to store the value 5 in it. Does that make sense? Right? So let's put that down. A variable is a memory location. A variable is basically used to store data in memory. That's the most important thing you need to know. So whenever you say I equal to 5, you are telling computer store the number 5 in memory for me. And when you say J equal to 6, you are saying computer, now I have 5 in I also have, I want you to store the number 6 in the memory location J. And then when you say K equal to I plus J, we are saying, computer, whatever you have stored in I, add it to whatever you have in J and store it in K, right? And then when I say print K, I am telling the computer, whatever you have in K, print it to the screen. Now let's look at these statements critically. For this variable, for every variable you see, variables are typically declared. So a variables are declared via declaration statements. So what is a declaration statement? A declaration statement involves, number one, an identifier. This is what we use to reference the variable. So in my little example, when I said I equal to 5, my identifier in this case is I, right? Now, the second part is the assignment operator. Now, this is typically would be the equal to, right? So we have the identifier, we have the assignment operator, then the last part would be the data we want to store, right? Now, this data can be anything, right? It can be a number, it can be a string, it can be anything whatsoever, right? So in this example, I saying I is equal to 5 is me saying I want to store the number 5 in I, in the location I or identifier I. Me saying I want to store the number 6 in J is me saying I want to store the number 6 in J. Right, good. So once we have variables, we can manipulate these variables in expressions, right? So for this case, an expression will typically mean me applying one or more operators to my variables. Or, okay, let's not get into that. One thing at a time. So expressions would be me applying one or more operators. So for numbers, for this, for now, let's focus on just working with numbers, right? So I can say, okay, computer, add I to J and store it in K. And I can say, computer, you know what? Divide I by J. Or I can also say, computer, multiply I by J, and then, or computer, subtract I from J, right? Now you would see that I'm not working with the numbers 5 and 6. I'm working with whatever data has been stored in those locations. And just for brevity's sake, I would print all of this. Print and print N, right? And I would run it. All right, so these are the results of all the manipulations we have done on these two variables, I and J. Okay, shoot.
Sorry, how do you do the exponents? For example, I raised to J.
Yeah, good. Nice question. So for exponentiation, you would use double asterisks.
Okay.
Sorry. I
think you
print
put 0 instead of O.
Yeah. So basically, that's that.
And root?
Roots, that's a bit complicated. I would rather avoid that for now. I would get into that. I would show you how to do that when we get to methods and functions. Anyway, so yeah, no problem. So basically, like I said, you typically work with variables and a variable declaration. This is my variable declaration. Then there's something else you need to know.
Hassan?
Go on. Someone wanted to ask a question?
I don't think so. You can go ahead. Yeah.
Okay. So when you write computer programs, because the art of writing software typically takes many days, you basically would need some way of reminding yourself, okay, today I was thinking I was writing this and this is the reason why I did this. So you typically do that using comments. And as far as Python is concerned, comments are represented by the hash symbol. Now, every other thing that comes after this hash symbol is for you and you alone. The computer does not care about it. The computer will not try to run this program. The computer will not try to execute it or try to make any sense out of it. So comments, I'll be using comments here to explain what we are trying to do as this thing progresses. So for this, I am declaring variables. This is how we declare variables in Python, right? And for today, we are working with numbers, I5 and J6. Now, to manipulate variables, you typically would use expressions, right? So everything we have written here is an expression, right? So we've declared variables, we've used expressions, right? And then for all these print statements, what we have simply done is that we have used variables, called methods on variables. So which brings us to the next thing. What is a method? A method is what you typically use to achieve something on your computer. So what does that mean? Sorry, it's a bit very basic to explain. I don't know how to explain it. Okay, so when you typically say do something, for instance, I'm telling this computer to do something, to print the variable stored at the location K or with the identifier K. Print is a method. Now, the exact details of what print does is not your business. You only care about what print does, the output, right? Or what it seeks to achieve, right? So methods are generally stuff or computer constructs or language constructs that allow you to encapsulate functionality. So what does that mean? So for instance, if I said in this our class of expressions, let's say K is equal to I plus J, but supposing I didn't want to, I wanted to make it reusable, I didn't want people to know what it meant to add A to B. I don't want them to know that adding I to J means I plus J, right? Now, I would typically use a method. So the first thing about methods is that we use it to hide the details of the functionality we are presenting to the user. So for instance, let's say I want to turn this into a method, to take this I plus J into a method. What does that mean? I would typically define a function. And when we are declaring functions, we typically start with the keyword def, right? And then the function name, right? Now this function will add into a number to another number, right? And then that would be now. Don't worry, I know some of you are like, what is happening here? Just a moment, we'll get right to it. So what I've simply done here is say, computer, I want a function, and this function will take inputs I and J. It can be anything. It doesn't have to be I and J. You can call it whatever you want to call it. And I want you to give me the sum. I want you to give me the result of adding var1 to var2. Now, how does this help us? So for instance, let's assume that we want to print the result of adding 5 to 6, right? We would just say print add 5 and 6. So I would comment out these lines and run this program again so that, good. So what has this done? Please note that this is not any different from what is happening here. K is equal to I plus J. Now, but what has simply happened is I have taken this expression and I have put it within the context of a function. And I have said, instead of whenever you want to add two numbers, you would have to type instantiate variable. Yeah, go on. Hello.
Do you want to ask a question? Like I said before, if you want to ask a question, you can just show by raising your hand, and then the instructor will wait and answer your question. Thank you.
Okay. So yeah. Now, so what I have just done is to say that if you computer, rather than add I to J. Oh. Hello. Do you want to ask a question?
I think I'm going to mute everybody. Yeah, just go on, Peter. I'll mute everybody.
Okay, so what I have simply done is say that, you know what, I know you are going to want to add I to J, but rather than you thinking in terms of how to add the details of what is into a function, right? So this is my function. I'm going to put all of this into a function, and I'm going to say that, you know what, if you want to add a number to another number, you don't need to know what it means to add. You just call the function add, and it would do the addition for you. So what this means, so for instance, in this case, if I wanted to add another number, say maybe I wanted to add another number after doing 5 plus 6, I would have to say I equal to 7, then J equal to 8, right? And then I would also have to say K equal to I plus J again, right? And then, sorry. Right? Now I am doing 2 additions, right? I'm doing 2 additions, right? Now, now how does this affect us as programmers? It means basically that the art of programming, as far as Python is concerned, is taking your expressions, which represent the kind of operations you want to perform on variables, and putting them into functions and having your users call those functions. So which means that when you are using a web application built on Python, you are consuming functionality that has been described in a function, right? So when you say login, what typically happens is that you supply your username and your password, and that username and password is shipped to a function on a server, and that function takes your username and your password and, you know, logs you in and verifies, are you the user, are you the password, are you the owner of this password, is the password match, etc., etc., and says yes or no, and so on and so forth. So which means basically, like I said once again, everything you would probably do in Python, you would have to, at some point in time, encapsulate it in a method or a function, sorry. So as part of our assignment, sorry, not assignment, just something to warm our fingers up. we would now define functions. I've taken the liberty of doing the addition function. So I would want us to do the division function, the multiply function, and the subtract function, the subtract function and the exponential function. So basically, if you don't mind, you can fire up your rep interpreter, which is this website I'm using on this page. You would create a function that you would call multiply. We will create a function that we'll call multiply. We'll have another function that we'll call subtract. We'll have another function that we'll call divide. And then we'll create the last function, which we will call exponentiation. Right? So let us begin. Like I said, to define a function, you start with the keyword def, right? Now, the next thing is, since we are working on multiply, I will type the word multiply. Now, I need to think about what will this multiply do. This multiply would take two numbers and return the result of multiplying them. Now, these two numbers would be anything. I really don't care. So, but I just need to assign a name to whatever the user passes in. So let's say, for instance, I can say num1 and number2, right? So in other words, this function would multiply num1 by num2. So what would we do? To multiply, we'll just return num1 times num2. That's our multiply function, right? The same thing goes if we want to subtract. Let's say we want to create a function called subtract. We'll do def subtract num1, num2. And then what will we do? Return num1 minus num2, right? The same thing, we want to create divide. We want to divide number1 by number2. We'll do def divide num1, num2, and then we'll say, computer, return the result of dividing number1 by number2, right? So on your own, I would like us to try to create a function for exponentiation. This function would take a number and another number and simply return the result of exponenting I number1 by number2. You could try this on your REPL, and when you are done, you can let me know.
So can we quickly try that? Let's take this as classwork so that we can really see the benefit of being in this class. Peter, could you scroll up a bit?
Sorry, just a moment.
So in case you want to talk now, you can raise up your hand. If you have any questions, you can throw it at him now while you continue to quickly go to this site and do what he has asked you to do. Thank you.
Okay, are we done? Just so that we don't spend a lot of time. So at the end of this, this is what you should have. You would have def, which is saying I'm defining a function. We can call that function exponentiate or exp or whatever. It doesn't matter. It can be whatever you want it to be. And this function will take, like I said, num1 and number 2, right? And then it will return the result of exponenting num1 with num2. So number 1 raised to number 2, right? So we have done all of this. Now that we have defined functions does not mean that they will be used automatically, right? I'll just, okay, I'll leave all of this. I would comment the print statement so that, now that we have defined methods does not mean that they would be used automatically. We have simply said, computer, this function encapsulates number 1 plus number 2, number 1 times number 2, and so on and so forth. But for these functions to make sense, to be used, we actually have to invoke it. Now, invoking a function simply means, for instance, I want to invoke the add function. What would it mean? It would mean I would have to start with the function name. The function I want to call is add. Now, from the function, it typically takes 2 values, right? 1 and 2. Now, they can be anything. So let's say 11 and 12, right? Now, I have invoked this function. Now, I can say, now, but because I want us to see the results, I would print the result of adding 11 to 12, or sorry, to 12. Now let's run that and see what happens. Yeah, good. So we see that 11 to 12, adding 11 to 12 gives us the number 23. I comment every other thing. In the same wise, let's say I wanted to use the multiply function. It's just the same thing. I would have to again call print and do multiply, which is the name of my function. And I'll say multiply 11 by 12, but it can be anything. The important thing is I have to pass in 2 numbers, right? Multiply 12 by 56. And then that result is 672. I can say print the result of dividing 12 by 6, right? Again, I am calling this divide function. I don't need to know what it does to give me the result. I just know that when I divide 12 by 6, I expect to get 2. Good. Now, and then also when I do 2 raised to power 2, which is 2 squared, I should get 4. I don't need to know what that means, right? You, the client, you don't need to know what is happening in the method. You just need to know that when I say raise 2 to the power 2, you expect to see 4, right? And basically, that does it. So 3 things that we have covered today that are very important into your journey as a software developer is, 1, we typically declare variables in a Python program. We'll apply operators to those variables that would give us an expression. And then we would typically call methods or use those variables and our